Hello everyone. Let us now discuss how can we solve this question. Find the largest almost missing integer. Here we are given with array nums and an integer k. Now we need to consider the subarrays of size k, and if x is known as almost missing if it appears in only one subarray. So let me take the first example and explain you how does this question works. Now k is 3. So I need to take a subarray of length 3. All the subarrays of length 3 would be this, like 392, 921, 217. So if I take 3, 9, 2, this is present in my first subarray. Instead, in zero indexed subarrays or zero indexing, it would be present in my zeroth subarray. Now, the next is 9, 2, and then 1. This is present in my first subarray. Now, 217, 2, 1, and then 7. This is present in my second subarray. So, here if you see, 3 is present in 0, right? 3 is present in 0, and it is not present in any of the other subarrays. If you see, 7 is also present in only subarray 2, and it is not present in any other subarrays. Instead, how can I change my approach of taking the number? Let me say that 3 is present in subarray 0, and the next element 9 is present in subarray 0, then 2 is present in subarray 0. Now I go to the next, which is 9 to 1. 9 to 1 are present in subarray 1. 9 is also present in subarray 1. 2 is also present in subarray 1. And 1 is also present in subarray 1. Next, I go to the next subarray, which is 217. So, 2 is present in the subarray 2 also. So, I would push back 2 is present in these subarrays. So, if you see, 2 is present in 0, 1 and 2 subarrays. Then 1 is also present in subarray 2. Now 7 is also present in subarray 2. But if you see, 3 and 7 are the elements which are present in only one subarray. Now, in this case, we need to return the maximum element, which is 7. But here, if you see, I am taking the elements, the integer value elements, and here I am storing a set which represents the subarrays the element is present in. So what I will do is start from I is equal to 0 and go till here, which takes the subarray of length 3. Now after that I go through these elements, the next k elements of I, from including of I, and get that into. So if I is 0, then my subarray is also 0. So I can get maximum of these only 3 subarrays. That means 0, 1, 2 subarrays. So I value would be my subarray value. So by taking this, let us solve this problem. By 397, I am at this position of I, which is 0. So 3 is present in subarray 0. 9 is present in subarray 0. 7 is present in subarray 0. So 2 is also present in subarray 0. If you see, my I value is 0. Now I am going to the next subarray, which is starting at I is equal to 1. Now I would change my I value to 1, and 9 is also present in subarray 1. Then 7 is also present in subarray 1. 2 is also present in subarray 1. 1 is also present in subarray 1. Then I go to the next subarray which starts at index 2. So this is the last subarray which I can get. So 2. Now 7 is also present in subarray 2 is also present in subarray 2. 1 is also present in subarray 2. And then like 7 is already present, right? 2, if I push back also, it would be something like, as this is initialized as set, you only get a subarray or the value as now I would return 3 because it is the only element which is present in only one subarray. So this is how we solve this problem, and this is the code where I initialize my frequency hash map, and int is for element and set of int store the subarrays where this element is present. Now I go through I is equal to 0 to n minus k and j is equal to I to I plus k. So frequency of nums of j dot insert I, that means I am inserting the subarray where this element is present. Now the my maxi is -1, and if f dot size is 1, that means the size of the element or the element is present in only one subarray, then I'll change my maxi to maximum of maxi comma element. So I will return the maximum element at the end. This is how we solve this problem. If you like this video, do share it to your friends and do subscribe to my channel. Thank you.